Really happy to have with us here today Paul Grizzaffi from Magenic. He's the principal automation architect at Magenic. His career is focused on creating and deploying automated test strategies. He holds a Master of Science in Computer Science, and he's a certified ScrumMaster. He's also an accomplished speaker. He's presented at both local and national meetups and conferences, and he's an advisor to the software test professionals and STPCon. So welcome to the stage, Paul.
Thank you. Is it hot in here? All right, well, thank you for showing up, and everybody awake after lunch, right? I'm trying to keep it a little peppy. We've got a lot of stuff to go through. So the title of this talk is, well, that's random, and I'm going to skip most of this who am I slide, except for the software pediatrician. Most of us have heard the old adage that the software developers are the ones who have the baby, and the testers are the ones that come in and say your baby's ugly. And what I prefer to think about is that we're the ones that come in and help that newborn, that fledgling software grow up into something mature, something that we can deliver, support, and adds value both to us and to our clients and users and customers. There's my contact info. It'll be up on the Q&A at the end, and I think if you go to the speaker bio stuff, it'll be there as well. But first, a little history. This goes back to when I was working at a telecom company back probably in the late 90s. And we were looking at tools to automatically generate unit tests for us. Not that that was a good idea. That's just what we were doing at the time. And we had it narrowed down to two. One would generate some unit tests with some known data. We could understand it really well, what it was doing. And then the other one would generate sort of test frameworks and then insert random data so that when you got different runs through, you would do it with different data. And at the time, it was something I couldn't really wrap my head around. The other architect and I agreed that that was not something we were prepared to kind of jump on. So we didn't choose that one. We chose the other one. Fortunately or unfortunately, that project as a whole got canceled one day. So that was probably for the best automatic generation of unit tests. But if I knew what I knew now about randomization, and some of the value that I've seen it actually bring, I might have made a different decision back then. So we'll talk a little about randomization and how it can apply outside of places we normally think that it might apply. So when we talk about testing today, what generally do we do? Regression testing, right? We've got this huge suite of tests, and we run these tests either with humans or with machines or some combination of both. And they're largely scripted out, and we run them every time with the same data and the same scripts, and we look for things that broke. Similarly, we have smoke tests, generally smaller, generally not as deep, and maybe we run these on every build or on every deploy to some particular environment. And then we have acceptance testing. Those of us that are doing Scrum or some sort of Agile, probably we have some acceptance criteria on our stories or work items or whatever it is that we call them. Also largely scripted, where it's make sure this works, make sure this works, make sure this works. Perhaps you've got some negative testing, some corner cases in there listed as well, but mostly these are confirmation. Confirmation that the way we understand it, we think it's working the right way. Then we've got things that are a little less scripted. Exploratory testing, and if you're doing proper exploratory testing, I'm no expert, but it'll be time-bounded and or time-boxed, and you'll have a charter, and there's certain things you go through. And then sometimes we just do ad hoc testing, otherwise known as playing around with the product. All valuable, all bring different types of things to the table. But what do we miss today? Particularly when we talk about the first three, and we're talking about regression, or smoke, or acceptance, there are things we miss, and a lot of it can be traced down to what's called the pesticide paradox. Who's familiar with the pesticide paradox? Oh, just a couple, okay. So roughly, the pesticide paradox is the idea that if you are going to test in a certain place, then that's where the bugs are not going to be. You'll chase the bugs out. Much like if you're spraying pesticide in your yard, where you sprayed, you're not going to have the bugs there. They're going to be somewhere else, in your house, in your neighbor's yard, but somewhere else because you sprayed the pesticide there. So where you're looking is where you're going to find the bugs and where you're going to kill the bugs. So what did we miss? the stuff that's off the beaten path, the stuff that is not intuitive. Now, exploratory and ad hoc cover some of this, but in the systems that we have today, particularly in the web environment, the systems are so interconnected, so many different moving parts, parts that are even outside of our own network. If we're dealing with banks or payment like PayPal or anything like that, we're now working with an external service that we're sending messages and data to and from, that we just don't have control of the flow of that data and to be able to adjust all the timings to check all the things that we would need to check. It's just not feasible in a reasonable and economical amount of time. So enter high-volume automated testing. Who's familiar with this? Thank you. So high-volume automated testing has nothing to do with actual high volume. There's lots of speakers there. But it's a family of testing techniques that allows a tester to create, execute, and evaluate an arbitrarily large number of tests. So this is not performance or load or capacity testing, anything like that. This is a different family of testing over a lot of the things we've seen before. Most of the, where's my little footnote here? There it is. So most, oops, wrong, there it is. So there's a link here, and you'll be able to get it from the slides or the video, of where the brunt of the initial research is from Kim Kainer and some of his folks down at Florida Institute of Technology. The next couple of slides and the information coming from those slides came from here. So I encourage you to go and have a read. I'm only going to do a very, very brief high-level explanation of it to kind of get you into the actual fuzzy browser stuff I'm going to talk about. But you can think of high-volume automated testing as broken down into 3 areas. One is exploiting existing tools or technologies or tests. And one of those examples would be what they call long sequence regression testing. I've actually used this particular thing in a different talk and to solve a different problem. But the idea is a lot of times in our regression testing, especially from an automation standpoint, what we do is we bring up the product and we run a crap load of tests against it, and then we take the product down. In some cases, we might bring up the product, run a test, and take it down, then bring it back up or reset it or something like that. Very good sort of clean room testing. You know what the situation is. You have a known steady state you're starting from. There's value there. But there's also value in running it more like your user base might run it, which is they're not going to take it down in between each transaction they make or each action they perform. It's going to be up, potentially for a while. So these long sequence regression tests are basically take your automated regression suite and keep running it, but get rid of all the test setup and tear down, or as much of it as you can to keep the product up and running. What does this find? Memory problems, timing issues, things that you don't catch when you run things in a vacuum, and issues that you don't catch if you don't leave the product up and running enough. Another is to exploit available oracles. And the example here is functional equivalence testing. And if you go to that website, there are many examples of under each of these. We just don't have time to go into the full brunt of them. But functional equivalence testing is you have thing A, and you want it to work like thing B. Thing B becomes your oracle. And the classic example is, hey, I've got a new operating system, and I'm going to write a new spreadsheet for it. I'm not going to come up with all those calculations myself. I'm not going to make all that math, right? What am I going to do? I'm going to run it against Excel. And whatever Excel's answers are, they need to be my answers. Might there be some bugs in Excel? Sure, probably are. But it's better economically in a lot of cases to actually do this functional equivalence testing simply because it's going to be cheaper for you to do that initial comparison. You can work with bugs later, but people sort of use Excel. So that's the de facto standard for spreadsheets. Why not use that as your oracle? Because it's already there. And then the third facet is tests that are focused on input and doing interesting things with input. And the thing we're going to talk about today there is fuzzing. Who's familiar with fuzzing? Okay, cool. All right. So fuzzing is, in essence, testing without an oracle. And I glazed over oracle there just a minute ago. But oracle is basically your source of truth. It tells you whether or not your test has passed. Or in our case for automation, our automated check has succeeded or not. Oh, he's not paying attention. Okay. So it's testing without an oracle. The, the idea here is you do things to the product, and you look for stuff that's weird. All right? We don't know what's going to happen if we take the entire text of War and Peace, a thing my friend does, and shove it into a name field or a zip code field in a form. But we have a pretty good idea of some things it shouldn't do. Shouldn't crash. Shouldn't give you a 404, shouldn't give you a 500, shouldn't give you anything other than some sort of indication that if it's acceptable to put that in a zip code, that, okay, this was a good zip code, or no, it really wasn't. So the idea is looking for things that are weird. And again, if you look back at the definition for high-volume automated testing, the core there is that the tester is evaluating the results. The tests, the automation, the checks, what have you, it's not coming back and giving you pass-fails. It's coming back and saying, here are the results of some things I did for you, or I'm the machine. You need to go through and evaluate whether there are problems or not. And that's what the fuzzing does. Hey, here's something that is weird. Perhaps you should go and have a look at it. And the idea, you're varying the inputs. You're going to shove in something big, something with multi-byte characters. Perhaps you're going to go to, I think it's called naughtystrings.org, naughtystrings.com, something like that. It's got this huge list of strings that can potentially blow up your text boxes. And we talk a lot about text boxes because when we talk about fuzzing, typically it is around text boxes. One of the ways to actually get fuzzing through is to inject some randomness. When I talk about randomness, I'm talking about a couple of specific things here. One is without a definite pattern. So there's no pattern that you can discern from the set of data that you're picking from. If you've got a bag of numbers, 1 to 10, on identical size and shaped cards, you have equal probability of pulling any one of those out. If you've got a fair coin, you have an equal probability of getting the heads or the tails. But there are two kinds of randomness, and I bring this up because it seems to be important because there's a whole website dedicated to true random. For our purposes here, pseudo-random is plenty. Pseudo-random is based off of a seed, a starting value, and then it's sort of computed this randomness where if you run it, if I understand it correctly, if you run it sufficiently long, you will find some sort of pattern in there for an egregiously large set of numbers. So for our purposes, it is sufficiently random. But there is this random.org where you can go out there and it's got some algorithm or something that will give you a truly random number if that's important to you. But one of the things that I had an issue with for that tool that I was looking at back when I was at the telecom company was, well, wait a minute, if we found an issue, how are we going to go back and reproduce that issue, fix the issue, and then show that it worked? Well, we need to have some reproducibility. We need to have some traceability. So we need to have what I call breadcrumbs. And breadcrumbs come in multiple things, but generally they are multiple different types. But you can clump them into different types of types. Wow. Maybe I needed to have different lunch. So steps. What did you do? How did you get where you were when you found this weirdness? Screenshots. If you have anything that's visual, take a screenshot. Because looking at what it was, because this is running unattended, right? And it's inventing its way through the system. You need to see what was there. You need to see what it looked like when it failed. If you're working with web browsers, dump the HTML, and message dumps. So when I say message dumps, we'll talk a little later about some of the things that we might be able to do with this technology going forward. But if you're doing anything with messaging or URLs or what have you, dumping out what you actually got back from the system might be interesting as well. So we talk about this in text boxes a lot. You hear fuzzing, fuzzing, fuzzing. It's almost always with text boxes. But why should they have all the fun? Why can't we do that with some of the other technologies that we produce? So enter the notion of a random clicker. So the random clicker is basically what it sounds like. It clicks random clickables. And clickables meaning anything you can click. Maybe it's on a website, it might be an A tag or a button or anything that has angle input, the input tag, whatever's clickable on your product, on your application, on your system. Because sometimes these things will be context dependent and you can create them very quickly, especially if you know that you're only working with your context. So clicks random things, looks for weirdness. Again, what's a weirdness? Well, anything that crashes, that's weird. You're probably going to have a human go and look at it and see, should it have crashed? The answer is always no. It should never crash. But how did it behave? Did it let me log in? Did I click on some stuff and not fill in any text and it let me log in? That would be weird. That would be weird. Logs the steps. It makes sure that you know how it got here. What did I click? Where did I navigate to before I found this weirdness? And it saves off the HTML and the screenshots. So you have this evidence to go back and look at what the weirdnesses were and decide if they're actual problems or not. Why do we do this? Seems weird, seems dumb, right? Well, it's cheap to build. The two examples we talked about, that we're going to talk about, one I built in an afternoon, one I built in 3 days. And we'll talk about the value each of them produced when we get to the actual examples. It goes through valid paths in the system. Things that the system allows you to do, whether it should or not. It's allowing you to do it. It's allowing the automation to do it. So it's valid. But it is often unintuitive because it is random. So as testers, we know how the system's supposed to work. So we check that. We know what some of the danger areas are. So we check that. If we have our users doing user acceptance testing or in the wild, they're actually using it to do their job, they're going to use it like they use it. We try to pretend to be those people and get in their heads. Sometimes we can do it, sometimes we can't. But we do our best. We can only do what we can do. They will do things on purpose. They will do things by accident. And we might have malicious people doing things on purpose to try and do end arounds on things, working through unintuitive backs and forths, back. How does all this type of stuff work? So it goes through the system on valid but unintuitive paths through the system. Again, huge systems, very interconnected, not programmatically or not economically feasible to go through all paths. It's not going to work. You're not going to be able to do it in any sort of reasonable amount of time. So the next best thing to supplement, this is not replacing anything, this supplements the testing and automation that we're doing now, is to go through these valid but unintuitive paths. And it works. It finds weirdnesses, and sometimes those weirdnesses actually are problems in the system. So here's a rough design. It's the item clicker. So we have the finder, the thing that finds what we want. Do we want all clickables? Do we want just links, just buttons, what have you? The item chooser. Do we want to do random? Do we want to do weighted random? Do we favor links over buttons or buttons over links or what have you? Or do we want to do it ordered? For some reason, we want to go through in some sort of orderly fashion and try and get everything. There are other products out there that would do that. I wouldn't invent that part there. The weirdness detector. So outside of obvious crash type things, you might have some context-specific weirdnesses. One of the products that we had was if error appeared anywhere, that was probably a weirdness because there weren't any web pages that should have the word error on them. So we would check for error. Is error there? If so, snapshot, HTML. We've been logging out the steps. We go back to a good spot. The fuzzer, if we wanted to add actual text box fuzzing to something like this, we could. Just have it as a separate module. So we need a text box finder. The item info logger, the things that is going to log out interesting items for particular elements. If we're going to click, well, we might want to know what the URL is, maybe the class name, maybe the ID, something so that is going to help us go back and do that postmortem and that triage of the weirdnesses that we find. And a login driver. Login driver is something we actually had to implement on the second example that I'll talk about, is because nothing interesting on the product could be hit until you logged in. It was behind a wall. So we had to log in, so we had to deal with credentials and having shared IDs and stuff like that. But once we were in, then we could randomly click stuff. So a rough implementation or algorithm, this is not the actual implementation for either of the two, because they were at companies I was actually an employee of, so they own that. But roughly, while we need to keep going, we're going to get all the clickables. We click it. We choose one randomly. We log out any of the information that's interesting, then click. Then we log out any interesting info about that page. So what URL did we click on? What URL did we land on? Is the title of the page interesting? Just whatever's interesting in your particular world. And then we check for weirdness. If there's a weirdness, then we also log out any of the stuff we would want to log out from a weirdness, like the screenshot and the HTML, and maybe if there are any other ancillary things that are interesting for us. And then we go back, because now we're at a state that we don't really know where we are, and we don't know if there's a back button, if there's another link we can pick on that page. So we say we're kind of out of bounds, so we start over. Otherwise, we choose a random link on the next page by saying, now we go back to the page after click, but we decide if we should keep going. Now, how do we stop? Doesn't matter. Pick something. X number of clicks, Y amount of seconds or minutes, Z number of errors. So I've done them different ways, and it just kind of depends on what works for you. So the actual two examples. The first one, well, actually before, we created, and they were called Scud at both companies. And if you're not familiar with Scud, Scud's the name of a missile that has the notoriety of having a very poor guidance system, where sometimes when you shoot the missile, it randomly goes off in some other direction. Not really good, but we took sort of that bleak analogy there and called our tool that, because it really just goes randomly through the site. The first one was an actual link clicker. You give it the URL. We had a set of hard-coded weirdnesses in there, and it would go until it found 3 weirdnesses, and then it would stop. So if it didn't find any weirdnesses for 4 hours, it would keep running for 4 hours. Took an afternoon to build, and we built that one in Ruby, because that was the language we were using at the particular company I was working at. And the first bug was found in 4 weeks. So a bug for a half day's effort, that's a pretty good deal. So cheap to build, and it works. The other one was a little more complicated. This was the one behind the login wall. And because of the nature of the product was older, aging, very complex. A lot of hands had been in it over the years, was not built for testability, and was certainly not built for automatability. What I quickly found out was once you logged in, there were very few interesting URLs, because the URLs were built on the fly from the menu system. And the menu system was popping up different elements with different IDs. So it took me longer to figure out how to navigate through the menu system. But what would happen was we would randomly pick one of the menu items, click it, and again, we'd look for the weirdness. If everything's cool, we'd click another menu item. So we were constraining it to the menu items, but that's because all of the interesting page transitions were via menu items, not so much links on the page. 4 issues in the first week. 4 issues in the first week. Now, the deck was stacked in my favor here, simply because we were doing a data center migration, so we were taking the existing software and putting it somewhere else, the strange new alien world with new network topology and infrastructure. So there were things that we knew just weren't going to work, and we weren't going to be able to get to everything. But we found 4 issues in just the first week. Any one of those that would have gotten out into production would have caused what we called a business critical incident. And on a business critical incident, that means all or part of the product is unusable for everybody or for key clients. And for that, we often had to pay a penalty. So there might have actually been a cash outlay from the company back to the clients because of any one of those 4. Now, I talk about what's found here not so much from a backpat from myself or the team, but to show that we're finding actual issues. concerning data through these non-traditional techniques, through these random clicks. So some additional algorithmic considerations that you may be interested in if you build one of these. Are you going to stay in the domain? And if so, how do you want to tell? In other words, hey, I clicked on something, and it said I'm going to go to something in my test domain. And then after my click, I look at the URL, and I'm in production. It's probably bad. You probably want to flag that as a weirdness. Or, hey, I've got links to Facebook and Twitter and all these other social media sites. Maybe I'm just not going to click on those at all. I'm going to skip that, and I'm going to repick a number, repick a random item. Too many clicks on the same page. Are you stuck? Is there no way to get off this page? Or are you on a SPA, a single page app, where you're actually going to be on the same URL all the time, but there's actual interesting things that are changing on the screen? You might want to tune number of clicks, whether you're on SPA or not. And it's restarting the algorithm or restarting the tool. The tools that we use here, for those two examples, were Selenium. If I ran it long enough, Selenium wasn't happy. Or at least the Ruby end of the Selenium wasn't happy. And I didn't even bother with it on the C# implementation because I knew that we might be having the problems. And is that it's not designed to run for hours and hours and hours. It's just not. So what we would do is every X amount of clicks, we'd say, let's restart. So we just take down Selenium and WebDriver and everything, recreate the objects, and go again. That takes care of memory leaks and memory eaters and things like that. So possible next steps, because what we're doing at Magenic right now is we have a prototype of a more generic one that we would be able to give to our clients. And it's not ready for prime time yet or anything, but it is going through and doing some random clicks, and we've got it generically configurable so that you can add your own weirdnesses and stuff like that. But possible next steps might be other input types. So right now we can do buttons and links, but we might want to look at generic forms and input tags and things like that. Thick clients. Why couldn't we do this with thick clients? I don't know a whole lot about the automation of thick clients, but I would imagine you could randomly grab some sort of button type or something there and click on that. Mobile, why not? Appium, Selenium, very closely related. We should be able to implement this for mobile as well. Text box fuzzing I alluded to earlier. We might want to inject text box fuzzing here, so sort of random on top of random. And API calls. Why couldn't we just jack around with API calls? Build your REST or your SOAP call just enough to make sure it's going to get to the other side, but jack around with the payload, jack around with some of the optional parameters, jack around with the size of things. Maybe you can cause problems on the far end. So just injecting random size-based or other types of items along there might be valuable in your particular context. And then to wrap up, so randomization is a powerful approach, but there are considerations. And most of the considerations are going to be around your breadcrumbs. What's going to be important to you on an unattended thing, an unattended piece of software that is going to potentially find something weird that you're going to have to go back and evaluate whether or not it is weird. Make sure you log all that stuff out. You dump all that stuff out. You'll learn. You'll miss things along the way. You'll introduce a lot of noise, and you'll find some weirdnesses and go, damn, this is so hard to debug. Let's get rid of this log and this step, and just different things. You'll tune it as you go. These non-conventional tools, they can be valuable, right? So we talked about a couple of examples where they actually brought value because they found traditional bugs just via a non-traditional way. And then when it comes to high-volume automated testing, there's a whole slew of types of stuff there. Some of it may be appropriate for you, some of it not. It just kind of depends, again, on your context. Building these can be quite easy and quick if you want it to be, or you can turn it into a huge project, whatever suits you. And then that's all the prepared stuff I have, so I can take questions now. Please wait for the microphone, if there are any questions. Oh, one in the back. Yeah, you did promise to heckle me, didn't you? No, but for the people on the video stream.
So I'm curious here, when you're running this, are you running it on local machines or are you going across the network like in a grid fashion to be able to, the way I'm envisioning some of the things you're talking about is your randomness is testing your application, but it could also be pulling up performance problems as well because of the traffic that you're sending through. So I'm curious, when you're running this, is it usually a local instance on a machine just sitting there running, or is it going across some sort of a grid, multiple node thing?
Historically, it's been single machine just because these have been kick it off, run it. It's a cheap, easy add-on to what we're doing. It hasn't been part of a formal automation or testing approach. But conceptually, I don't see any reason why we couldn't run it remotely. One of the experiments we do plan on having is trying to run it with Sauce Labs and see, what will we have to change on our side to be able to manage multiple browsers at the same time? Running one browser on a remote shouldn't be a problem, but if we're going to do multiples at once, which is a lot of what Sauce would bring to the table, right? So pick one of each browser type and run. I don't know. I don't know what that looks like yet. All right. Oh, yep.
There you go.
So how about scrollables, looking for scrollables, paging or paging through things or paging up and down, or if you've got an application with a lot of paged text or things like that. Have you experimented with that?
Not directly with scroll up, scroll down, but what we did in the implementations was we would get all of the anchor tags on the page, all the A tags on the page, and then randomly pick one. But what we built into our click method was scroll to it if it's not visible, and then click. So we wouldn't get the element not visible errors back out. But we didn't do any actual, there were very little brains in this. It's very much a sort of a dumb monkey kind of thing, where it's turning a crank for you. The idea of it being cheap to build, anything it finds is gravy. So we didn't get very sophisticated with locating or different types of specific testing or checking with it.
Yeah.
Yes.
Can you define a little bit on the weirdness, or how do you define there's some weird behavior on the page when you do a click? What's the logic to identify that weirdness?
So the logic was basically brute force. You have a list of things to consider weird. If your website has its own 404 page, like a lot of websites do, look for the text on that page. Or the URL. Maybe you have your own URL for that particular page. Looking for 400, 500. You go through and look at what the different crashes look like. If it says DBC error, yeah, you're probably not supposed to see that on any of your pages. So we grep for or search for a lot of things in the text of we get the page source and grep for a lot of things in there. And then there are other things we can do, like look at URLs for if I got from my QA environment to my production environment, or the way we wrote it was if I leave the environment at all, that's considered a weirdness. So we'd flag that and then start over as well. So it's going to be context dependent. Perhaps in your world, your product, it's valid to have the word error on some of the pages. So maybe you don't want that to be a weirdness. You want something more specific than that. Whereas the one we had, error should never appear. Sure. Okay.
So how much percentage of coverage you think is sufficient for us to say that, yes, we have done enough testing in a page? I mean, if you have like 20 links or 20 clickables in a page, you would randomly pick one and move to the next page. And what is the criteria here? How do you define that?
So I would not really consider this really a coverage tool. I guess you could measure coverage on it, but just from a click something and should I move to the next page, that's just the way the algorithm's designed. If you know there are more interesting things on the page, you certainly could try and click multiple things on the page. Like if you know you have to click 6 different buttons in order for the continue button to be activated, certainly you could build that logic in, or you could randomly click several times on the page. This is where we start getting into the more context-dependent things that are going to, context-dependent situations that are going to matter for you, but may not matter for him. All right, well, thank you, everybody. I want you to get off to your next session.